Hello, this is Swati Shivkumar and I will be taking a lesson on experimental methods and least count part 1. The first instrument we will be seeing is Vernier Callipers. This is an instrument used for making very accurate linear measurements. This is widely used in scientific laboratories and in manufacturing for quality control measurements. Let's see the uses of this instrument. It is used to measure the length of a rod or any object, the diameter of a sphere, the internal and external diameter of a hollow cylinder, the depth of a small beaker, etc. Coming to the components of Vernier calipers, the main scale is graduated in millimeter and centimeter on one side and in inches on the other side. It's just like a meter scale. Coming to the other component, which is the Vernier scale, it's a sliding scale which is parallel to the main scale, which enables the reading to be made to a fraction of a division on the main scale. That is, it increases the accuracy. There's a screw which helps Vernier scale to be fixed to the main scale, that is, it does not move during the measurement is taken. There are two pairs of jaws, one for the internal measurements, that is, internal diameter of a beaker can be measured using this internal jaw, and the external jaw can be used to measure the external diameter of an object or the diameter of a sphere, etc. The strip can be used to measure the depth of objects like beaker or any hollow object. Now, coming to the principle of Vernier calipers, the length of n divisions of the Vernier scale is equal to the n minus 1 divisions of the main scale. The least count of Vernier caliper or Vernier constant is the value of one main scale division divided by total number of divisions on Vernier. As we said, the Vernier scale has 10 divisions and each division of main scale is equal to 1 millimeter. So the least count of the Vernier caliper will be 0.1 millimeter or 0.01 centimeter. Moving on, how do we use a Vernier caliper? This is the image. And the procedure is, the jaws are kept in a manner such that it encloses the object to be measured. That is, the object is kept here and the jaws are enclosed. It is tightened using the screw here. And the main scale reading is noted. That is, the 0 of the Vernier scale coincides with a division in the main scale, and that division is the measurement for the main scale, called as the main scale reading. Now, the division on the Vernier scale coinciding with any division of main scale is noted and multiplied with least count, which is the Vernier scale reading. Now, any division on the Vernier scale other than the 0 coincides for sure with the main scale. That division is taken into consideration. It is noted down and it is multiplied to the least count, which is 0.1 millimeter, to give the Vernier scale reading, and the observed length is found out or calculated by adding the main scale reading to the Vernier scale reading. So the observed reading will be main scale reading plus the product of Vernier scale coincidence into least count. That's Vernier calipers. Moving on to the next instrument, the screw gauge. It is used to measure very small lengths or thickness up to 1/100th. There's an error. It's 1/100th part of a millimeter, which is 0.01 millimeter. Used to measure diameter of a wire, thickness of a metal sheet, etc. The components of a screw gauge are a frame. There's a U-shaped frame which has an adjustable nut to one side, and there's a fixed stud with a plain face on the other side. That is, the object to be measured is placed in between the U frame. The main scale has an extended portion of nut with a baseline along the axis and is graduated in millimeters and half milliliters. There's a thimble, which is a hollow cylinder at the end of the screw. There's a circular scale. The circular scale is found on the thimble and it is graduated to 50 or 100 equal divisions. Usually it is 100 equal divisions. And there's a ratchet which avoids undue tightening of the screw and helps us hold the object between the stud and the end of the screw. That is, it keeps the object in place so that the measurement can be taken. The principle of screw gauge is, when rotated just like a screw, there is linear motion as well as rotational motion. So there's one term that we have to know, which is the pitch of the screw. Pitch of the screw is the linear distance traveled by the screw when the circular is given one complete rotation. That is, when you rotate it completely once, the distance traveled linearly by the screw is the pitch. So this can be calculated and is found to be 1 millimeter for screw gauge. The least count can be calculated by dividing pitch of screw by the total number of divisions on the circular scale. As we saw earlier, the circular scale has around 100 divisions. So 1 millimeter divided by 100 is the least count, and it is 0.01. It's not 0.001, there's an error here. It is 0.01 millimeter. Moving on, how to use this screw gauge. The object is placed in between the U frame. Let the object be a wire, and it is tightened using the ratchet. And once tightened, the circular scale division coincides with the base line. We saw that the main scale has a base line along its axis, and it is coincided with a value on the circular scale that is noted, and that into the least count gives the circular scale reading. The circular scale division into the least count gives the circular scale reading. Now the main scale reading is the reading which coincides with the zero of the circular scale divisions. So the main scale and the circular scale readings are taken. The main scale reading plus circular scale gives us the observed reading. That is main scale reading plus the product of circular scale and least count. So that was screw gauge. Thank you. The next lesson will be on experimental methods and least counts, part 2.